Hello. Today we're going to continue talking about chapter 2, and we're going to look at some terms like element, compound, atom, molecule, and so on. And we're going to count up molecules and atoms together. So let's first start by some definitions. So an element, we already talked about what an element is. It's a pure substance that cannot be broken down by chemical means, physical or chemical means. So let's write that down. A pure substance that cannot be broken down by physical or chemical means. Some examples of elements. We have 118 elements or so on the periodic table. So carbon, copper, gold, sodium, a lot. Okay, a compound is where you take two or more of these elements and bond them together chemically. So it's still a pure substance, but it's made by combining two or more different elements chemically. Let's write that down. A pure substance. So both elements and compounds are pure substances that is made by combining two or more different elements chemically. So example would be H2O, NaCl, H2SO4. These are all compounds. I'm going to add one more example to my elements here. Hydrogen. Let's do two more. Oxygen. Those are also elements. Okay. Next one is an atom. So an atom is the smallest quantity of an element that retains its properties. Let's write that down. The smallest quantity of an element that retains its properties. So, for example, I can say I have one atom of carbon, or 3 atoms of sodium, and so on. So the term atom kind of signifies quantity. So if I see C like this, I'd say, oh, the type of substance is an element. But how many of it do I have? I can have 1 atom, I can have 5 atoms, I can have 100,000 atoms. And so an atom kind of tells you the quantity. It's the smallest unit. So an atom is a unit of an element. So how many units are there? That tells me how many atoms are there. Okay, next one is molecule. So a molecule is when you have 2 or more of these atoms bonded together chemically. And they don't have to be different elements bonded together. Like the atoms could be of the same element. For example, I can have 1 molecule of NaCl. Or I can have maybe 2 molecules of O3, which is ozone, or 5 molecules of fluorine, F2. So they can be different elements, or they could be the same element, just at 2 or more atoms bonded together to make a molecule. A chemical formula is a formula that shows you the kinds and number of the kinds of elements and the number of atoms in the smallest representative unit of a substance. Let's write that down. So a formula showing types of elements and the number of atoms in the smallest representative unit. I should just say unit, not units. Of a substance, whether that substance is an element or a compound or whatever. So for example, if I write O3, that is the chemical formula for ozone. So in the chemical formula of ozone, I have 3 atoms of oxygen bonded together to form a molecule of ozone. Or let's say sulfuric acid is H2SO4. So this is the chemical formula for H2SO4. So that tells me that a molecule of H2SO4 has 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. All right, so let's see if we can look at these particle diagrams, and then later we're going to look at these formulas. So these are particle diagrams right here, and these are chemical formulas. And we're going to hopefully be able to answer these questions here. So first, we're going to look at each of these and decide, is it a pure substance or is it a mixture? If it's a pure substance, then it will be one type of substance, right? But if it's a mixture, how many different substances make up that mixture? And are these different substances elements or are they compounds? And how many molecules do we see and how many atoms are there? So let's start with the first one. So this one right here, is that a pure substance or is it a mixture? So that is a pure substance. I'm going to write P for pure. The way I know that this is pure is because I see the same types of units everywhere. They're all the same. So this whole thing is the same as this whole thing, is the same as this whole thing, and so on. All of them look the same to me. So that means it's a pure substance, which means there's only one substance. And I use sub for substance, short for substance. Only one substance. Is that substance an element or a compound? Well, in this case, it is one element. And how many molecules are there and how many atoms are there? So molecule is a group of 2 or more atoms bonded together chemically. So when we draw them next to each other like this, that means that it's bonded together. So this is a molecule, there's another molecule, there's one, there's one, there's one, there's one. So 1, 2, 3, 4, 5, 6 molecules. But then each of these molecules is made up of 2 atoms, and so that would be a total of 12 atoms. Okay, and this is an element because both of these are the same, so that would be like H2 or O2 or N2. It's a diatomic element. All right, let's move on to the next one, this one right here. So is this pure or is it a mixture? So as I look at this here versus this one here, those look different. So that looks to me like it's a mixture. I'm going to write M for mixture. How many different substances is this mixture made of? Well, it looks like some of them look like these, and then some of them look like this. It looks like two substances. Now, are these substances elements or compounds? Let's look at this one. Is that an element or a compound? That's an element. How about this one? It's also an element. So there are two elements. I'm going to write 2E for elements. Okay. How many molecules are there? Well, the answer is 0. 0 molecules. Why aren't there any molecules? I see lots of atoms here. In fact, there's a total of, if you count them, 15 atoms. So how come there are no molecules? Because none of these atoms are bonded together. Remember, a molecule means 2 or more atoms bonded chemically. And the way that we show that on particle diagrams is we show them touching each other like this. Okay, let's look at the next set of 2 particle diagrams. This one right here, is that pure or a mixture? Well, it looks like all of them are the same thing to me, so that looks like it's pure, which means if it's pure, it's only one substance. And is that substance an element or a compound? That looks to me like an element. How many molecules are there? You got it, 0 molecules. Nothing is bonded to each other. And then how many atoms are there? Let's count them together. 9 atoms. Okay, let's look at this diagram. Okay, as I look, I see this whole unit is one thing, and then there's these little ones. So that looks to me like a mixture. How many substances are in this mixture? Well, this and this and this look like one substance, and then all of these look like another substance, so it looks like 2 substances. Are these 2 substances elements or compounds, or one of each? So this substance looks like it's a compound. You have 2 different elements bonded together, right? But this looks like an element. So in my substances, there's 1 element and 1 compound. And then how many molecules are there? There's 1 molecule, 2, and 3. So 3 molecules. And then how many atoms? Let's see, each of these molecules has 1, 2, 3, 4 atoms. So there's 4 and another 4 and another 4. So those all together are 12. And then 15, 16, or sorry, 12, 13, 14, 15, 16, 17, 18. 18 atoms. Okay, let's try to do the same thing that we just did, but for some formulas as opposed to particle diagrams. So H2O. If it helps you to draw a particle diagram, you are welcome to. H2O would look like this. H2O looks like Mickey Mouse, actually. So the smaller ones, those are the hydrogens. There's the oxygen here. So if I have a particle diagram that just has this, just an H2O. Well, that is pure. I only see one type of substance. So one substance. And is that substance an element or a compound? Well, that is a compound. You have hydrogen and oxygen bonded together. All right, how many molecules? Looks like there's only 1 molecule. And how many atoms? There are 3 atoms, 2 hydrogens and 1 oxygen. Switch my color here. Okay, F2. So if I drew a particle diagram for this, it would look like that. Right? That subscript means those 2 are bonded together. So this looks to me like a pure substance. So that means 1 substance. If it's pure, that means 1 substance, right? Is it a compound or an element? This is an element. They're both F's, right? They're both fluorines, so it's an element. How many molecules are there? There is 1 molecule. 1 molecule made up of 2 atoms bonded together. 2 fluorine atoms make up 1 molecule of F2. Okay, next one. KMNO4. So if I wanted to draw a particle diagram of my KMNO4, let's say there's my K, there's my M, N, that's MN, that's the K, and then I'm going to do 1, 2, 3, 4, that's my O4. So it's a pure substance, which means it's one substance. That substance is a compound, and I only have one molecule of that compound. What if I had two molecules? What would that look like? You'd see like a 2 there. And then you draw another one of those things here. And how many atoms are there? Well, there's 1 K, 1 Mn, and then 4 oxygens, so that's a total of 6 atoms. Okay. Let's go to the next one, CaOH2. So, just like all the other ones, that looks like a pure substance. There's only one substance there, which is a compound. And I have one molecule of that compound. And how many atoms? Well, that 2 distributes, right? So there's 2 hydrogens and there's 2 oxygens. So that's a total of 5 atoms. Let me draw a particle diagram for you so you can see it. So I would have just a CaOH2. So let's say this is my Ca. And then there's my OH. And then another OH. That OH with the parentheses 2 means there's 2 OHs. 2 of the hydrogens, 2 of the oxygens. That's a total of 5 different atoms. Okay, next one. So 2Na, and so 2Na, that's a pure substance, which means it's just one substance, just sodium. Sodium is an element, so that one substance is an element. How many molecules are there? Don't let that trick you. 0 molecules. But how many atoms? There are 2 atoms. So let me draw this one for you to distinguish between that one and the F2 that's in blue here. If I have 2 NAs, there's an NA and there's another NA. So look at the difference here. There's 2 in front. So that tells you it's just an Na, but there's 2 of them. So this is just an Na and there's 2 of those. Versus this one, the F2, there's only one F2, but that F2 is made up of 2 Fs bonded together. So notice that it's a subscript here, but it's a coefficient here. So when it's a subscript like that, that tells us that both of these are bonded together, whereas this one, they're not bonded. There's just 2 of this individual Na. So watch out here. All right. Next one is 3CO2 plus 6Si plus 2H2O. What do you think? Pure or mixture? That definitely looks like it's a mixture. And we have 3 different substances, right? And this is a compound, this is an element, and this is a compound. So we have 2 compounds and 1 element. All right, let's look at the molecules. Are there any molecules here? Yep, these are molecules, so there's 3 of those. Any molecules here? Nope. Those are just individual atoms. Molecules here? Yep, there are 2 of them. So there are 2 molecules of water, 3 molecules of H2O for a total of 5 molecules. Let's count up how many atoms. So each of these CO2s has 3 atoms, and there's 3 CO2s, so 3 times, these are 3 atoms there, so that's 9. And then these silicon, they're just individual atoms, there's 6 of them. And then there are 2 waters, and each of the waters are made up of 3 atoms. So you add them all up together, you get 21 atoms. I'm going to go ahead and draw a particle diagram for that for you. I'm going to draw it down here for you. So make it like that. All right, so CO2, let's start with the CO2. So there's, let's say, the carbon and 2 oxygens, and there's 3 of these. So there's that one. There are your 3 CO2s. Then we have these 6 SIs. So I'm going to make those maybe bigger. 1, 2, 3, 4, 5, 6. Let me put like a line through them so we know, can distinguish them. All right, so there are my 6 SIs. And then I have 2 H2Os. So my H2Os, there we go. So if you look at these are 1, 2, 3, 4, 5 molecules. These are not molecules, they're individual atoms. And then if you count up the atoms, there should be 3 plus 3 plus 3. That's 9 plus 6. That's 15 plus 3 plus 3. So that's a total of 21. All right, last one. What color should we make that one? Let's make it this blue. All right, so we have 5Al2SO4 3. Wow, so that is a pure substance, which means it's one substance. And that substance is definitely a compound. You can see there's all different elements in there. And there are 5 molecules. I know that because each of these is a molecule, and there's 5 of those. But then how many atoms? So let's see. Al2SO4 3. So let me write it here again. I'm just going to write one of them. Okay, so that 3 distributes, right? It goes here and it goes here, just like in math. So each of these molecules, there's 5 of them, right? But each one of them has 2 aluminums, has 3 sulfurs, and then how many oxygens? 3 times 4 is 12 oxygens. Altogether, 17 atoms. 17 atoms in just one of these things, but there are 5 of them. So 5 times 17, oh my goodness, what's that? 85. That is a lot of atoms. If we drew a particle diagram, I'm not going to draw the whole particle diagram, but basically you have your aluminum. So 1, 2 aluminums. Then you have sulfur with 4 oxygens, another sulfur with 4 oxygens, and another sulfur with 4 oxygens. That's one of them. So there's 5 of this whole thing, if you were to draw a particle diagram of that. All right, now what I'd like you to do is to take a look at the counting atoms and activity and try to do the same thing. Look at the different things that you have in front of you. Try to figure out if it's a pure substance or a compound, how many substances there are these substance elements or compounds, and then count up how many molecules and how many atoms.